Nani, do you think these some are polluted?
I'm not sure, but we can use gravimetric analysis to find out.
What is gravimetric analysis?
So first, what is gravimetric analysis? A gravimetric analysis is a quantitative analytical technique where the analyte is converted into a stable, solid form that can be weighed. It is often used when the substance to be analyzed can be precipitated selectively and with high purity. Gravimetric analysis is a precise method, but it can be time-consuming and require careful handling to avoid contamination or loss of precipitate. Gravimetric analysis can be used for determining the composition of complex mixtures or trace amount of substance. One of the purposes of gravimetric analysis is in water environmental analysis. In the context of water environmental analysis, gravimetric analysis can be used to quantify the concentration of specific substance, often being the pollutant present in water samples. This analytical technique relies on measuring the mass of a substance, typically in solid form, that can be derived from the water sample through chemical reaction or physical process. This is because to monitor the water quality, identify the sources of pollution, evaluate the impact of industrial activities, and to ensure compliance with environmental regulation.
Next, we're going to continue with the theory of gravimetric analysis. Gravimetric analysis is an analytical technique used to determine the quantity of an analyte based on the mass of a solid. The method involves converting the analyte into a solid that can be isolated and weighed. This process relies on the precision of mass measurements, ensuring accuracy in quantitative analysis. There are 4 steps in gravimetric analysis. First is precipitation, next filtration, then drying, lastly waving and calculate. The chemical reaction in gravimetric analysis is designed to quantitatively convert the analyte into a stable insoluble compound. The chosen reagent must selectively react with the analyte without interference from other components in the sample. To precipitate mercury from a polluted lake sample, we can use a sulfide source such as hydrogen sulfide or sodium sulfide. To calculate our result, molar mass and stoichiometry, the mass of the precipitate, is used to calculate the amount of analyte in the sample. Using the molar mass and stoichiometry of the reaction, the quantity of the analyte can be determined. These are the examples of the calculation to determine the concentration of magnesium in polluted lake.
So let's take a look at the methodology of gravimetric analysis to determine mercury in water. The apparatus that will be used in this experiment are clean contaminant-free bottles, 0.45 microfilters, Bushnell funnel, pre-weighed filter paper, analytical balance, oven, pH meter or pH strips, and lastly stirring roots. The first step is sample collection and preparation. To ensure a representative analysis, water samples are collected from multiple locations in the lake using clean contaminant-free bottles. The collected samples are then filtered through a 0.45 microfilter to remove suspended solids that could interfere with the analysis. To stabilize mercury ions and prevent them from adhering to container walls, the samples are slightly acidified with nitric acid. Next, we will do precipitation process. The precipitation process begins with the preparation of a sodium sulfide or hydrogen sulfide solution as the sulfide source. The pH of the water sample is adjusted to around 2 or 3 using dilute nitric acid, creating an acidic environment that helps keep mercury ions in solution. The sulfide solution is then slowly added to the acidified water sample while stirring continuously, ensuring uniform distribution and preventing local oversaturation. This results in the formation of a black precipitate of mercury sulfide. The mixture is allowed to stand for about an hour to ensure complete precipitation. So, for filtration, Bushnell funnel with a vacuum filtration system is used for efficient and rapid filtration. A pre-weighed filter paper or a sintered glass crucible is placed in the funnel. The sample is then filtered to collect the HGS precipitate on the filter medium, and the precipitate is rinsed with distilled water to remove soluble impurities. Next, we need to wash the precipitate. Washing the precipitate removes impurities that could add to the mass of the precipitate, ensuring accurate results. The precipitate is washed several times with small amounts of cooled distilled water. For the final wash, a dilute solution of an acid may be used to remove any adhering impurities without dissolving the HGS precipitate. The fifth step is drying or ignition. The filtered precipitate is dried in an oven at 105 to 110 degrees Celsius to remove moisture. The drying process continues until the precipitate reaches a constant weight, indicating that all water has been removed. Although HGS is typically stable enough to be weighed directly after drying, some analyzers might require ignition at a high temperature to convert the precipitate into a stable, non-hygroscopic form. Then, the dried precipitate is weighed using an analytical balance with a precision of plus minus 0.001 gram. The mass of the HGS precipitate is recorded accurately. Lastly, for the calculations, the mass of the HGS precipitate obtained from the weighing process is used to calculate the concentration of mercury in the water samples. Move to the next slide, application and example. This can be applied in case study for determination of sulfates in water. In a practical application of gravimetric analysis, let's consider the determination of sulfate concentrations in the water sample from a polluted lake. The procedure involves collecting water sample, precipitating the sulfates, and measuring the mass of the resulting precipitate to calculate the sulfate concentration. So, for the example, once we have the precipitate, the data interpretation begins. For a 1 liter water sample, we first obtain a precipitate of mercury sulfide. This precipitate is then dried and weighed. In our example, the weight is 0.150 grams. The molar mass of the HGS is the sum of the molar masses of mercury and sulfur, giving us 232.65 gram mole. By dividing the mass of HGS by its molar mass, we determine the moles of HGS, which is approximately 6.45 times 10 in the power of negative 4 mole. Since each mole of HGS corresponds to 1 mole of Hg2+, the moles of Hg2+ are the same. The concentration of Hg2+ in the water sample is then 6.45 times 10 in the power of negative 4 mole. To express the concentration in mg per L, we convert the molar concentration of Hg2+ to a mass concentration, multiplying the molar concentration 6.45 times 10 in the power of negative 4 mole per L by the molar mass of mercury, which is 200.59 G per mole, give us 0.129 G per L. Converting this to mg per L by multiplying by 1000, we get 129 mg per L. Thus, the concentration of mercury in the polluted lake water is 129.
We continue the example with comparison with water quality standard. To assess the water quality, the measured sulfate concentration is compared with established water quality standards. For example, the World Health Organization (WHO) guideline value for sulfates in drinking water is 250 mg over liter, while the US Environmental Protection Agency EPA also sets a secondary maximum contaminant level SMCL of 250 mg over liter. In this case, the measured concentration of sulfates in the lake water is 96 mg over liter, which is below both the WHO guideline and the EPA SMCL. This indicates that, at least in terms of sulfate concentration, the lake water is within acceptable limits for drinking water standards. However, further analysis for other contaminants will be necessary to determine the overall water quality. For conclusion, gravimetric analysis is a fundamental method used in water testing to determine the concentration of certain substances by measuring their mass. This technique in water testing, due to its accuracy, simplicity, and cost effectiveness, it is particularly useful for measuring suspended solids and providing essential data for environmental monitoring and regulatory compliance. Despite its labor-intensive nature and time requirement, the robustness and reliability of gravimetric analysis make it an indispensable tool in water quality assessment. Future advancements may streamline the process, further enhancing its utility in various water testing applications. So that's all from us. Thank you.
Oh, now I understand. Thank you for the interesting information.
Okay.
That's all from us. Don't forget to like, share our video. If you have any question, just leave your comment below.